Thanks for joining us for Spa Parts Plus Spa Troubleshooting Video Guides. We have produced a series of tapes to show you the basics of portable spa repair. The systems that you'll see in the tape aren't necessarily representative of the systems that you'll run into in the field. But the methods and the techniques that we'll show you here do apply to virtually every system that's in the field. If you have any questions with regards to the content of these tapes or any of the systems that you run across that we haven't covered in these tapes, feel free to give us a call. We're here to help. I hope that you do enjoy the series, and now, here's Tim.
As you probably know, the pump is what circulates water through the spa, but what you may not know is that the pump is made up of two basic components. There's the wet end and the motor. Let's go inside and we'll take a closer look at this system. The wet end moves water by centrifugal force. Let's take a look at the four basic parts that make up the wet end. First, you have the housing or the volute. Then you have the housing cover or inlet. Then there's the impeller, and finally the shaft seal assembly. Here's how they fit together. You'll usually see the pump housing attached to the motor housing with 4 bolts. Pressed into the pump housing and onto the impeller are the 2 parts of the shaft seal, which keeps water from leaking down the motor shaft and into the motor. You can also see that the impeller can be threaded onto the motor shaft, as it should be. Now here are the 2 parts of the shaft seal pressed together, and that forms our watertight seal. The housing cover then seals the open end, and we've created our pump. Here's what happens when we turn the motor on. Water passes through the inlet housing cover, and it goes into the rotating impeller. Now, it's the rotation of the impeller that draws water into the pump housing, which sends water out the discharge of the pump. As you can see, it's the constant discharge of water that creates water flow. I've mentioned that the pump consists of 2 basic parts. We've discussed the wet end. Let's go on now to discuss the electrical motor, which comes in a variety of horsepowers from 1/16 horsepower and up, 120 to 240 volts, and 1 or 2 speeds. Occasionally, a smaller single-speed pump will be used for circulation, filtration, and heating, while a larger pump is used to pump water to the jets. A 2-speed pump uses the low speed for circulation, filtration, and heating, while it's the higher speed that creates water circulation for therapy. Occasionally, a second pump also will provide additional therapeutic effect. Now, let's take a look at our troubleshooting flow chart, and we'll troubleshoot the pump system. Our first problem is that the jets aren't working. So we have to ask this question: is the high-speed pump motor running? Well, obviously in this case it is not. So what we're going to do now is check to see if there's proper voltage here. Using our multimeter, we'll check for correct voltage at the low speed and neutral terminals. And we see that we don't have proper voltage. So the next thing we're going to do is check to see if we have proper voltage at the source. And again, using our multimeter, you can see now that we do have 120 volts, so there's a problem between the source and the pump. We're losing voltage. We would now check our wiring or cord sets and repair or replace it. Another problem you may run into is that the system is not filtering. First, we're going to check to see if the low-speed motor is running, and obviously in this case it's not. So we have to find out if it's getting proper voltage. Easy enough to check with our multimeter. Take out our plug. There we go. Okay, you can see that we're not getting proper voltage there. So we're going to determine how the low-speed motor is controlled, and it can be either with a time clock or a thermostat. In this case, ours is controlled with the time clock, timed heat, as you can see here. So now what we're going to do is check and see if there's correct voltage at the load side of the time clock. Again, using our multimeter, we'll come down here, and we have no, or at least we do not have the proper voltage, I should say. So last but not least, we're going to go now and check our source and see if we have proper voltage there. And there you have it. We have the proper voltage. So our problem must be a faulty time clock. Let's go out into the field now. We're going to troubleshoot a real system. We're on location again with our spa technician, Doug Clark. And Doug, what's the problem in this situation?
Well, Tim, our homeowner's complaining that the spa keeps running 24 hours a day. The heat keeps cycling on and off like it should, and it's maintaining temperature without overheating, but the low-speed pump wants to continually run. Seeing that, making sure that we are in the low-speed mode and not the high-speed mode, we're going to check the thermostats, both thermostats, to make sure they're turned down. This one is, and we see that this one is. Now, we have two modes here. We have the thermostat mode and the time clock mode. What we want to do is we want to make sure that all the time lugs are out, and once we've done that, we're going to turn the clock around about 48 hours to see if there's any reason that might trip that off, but it hasn't.
Right.
Seeing that it hasn't, we're going to have to get inside here and see what the problem is.
Okay.
Now, I've already removed the screws, so this will open quite easily. And Tim, if I can impose on you to hold open that door for
Sure.
me, we'll just hold it right there. Now, what we're going to do is we're going to take our voltage leads and we're going to put them on the load side of the GFI, and we're going to come right to this thermostat. Now, we know that there's only two things that operate the low-speed pump, the thermostat and the time clock. So this being the point where both thermostats come together, I'm going to take my voltage lead, or tester, and go right to the line side of the thermostat. Now, by putting it there, I can see I have 110 volts, 120 volts. Okay, with the thermostat off, we should not have any voltage on the other side, and seeing we don't. So what that's told me is that both thermostats are in a normally open position where they will not allow power to go on through to the pump.
Okay, so where do you go next then?
Well, the only other mechanism that operates the clock or operates the low speed of the pump is the time clock. So we're going to go right to that. Now, we'll go to the line side of the time clock. See that we have voltage coming in? And we do. And knowing that the clock is in the off position, we should not have voltage coming out, but indeed we do, Tim. So with the clock being in the off position, and we have voltage going through, that's telling me that those contacts in there are welded closed and it is allowing voltage to go on through. So to sum it up, that's our problem right there.
Just replacing the time clock should solve our problem.
That's exactly correct. We're going to replace this time clock and that'll solve our problem.
Good enough.
You bet. Okay, Tim, now I've shut the power off to the breaker and I've already gone ahead to remove the screws. Now what I like to suggest is that we go wire for wire, and that kind of keeps it simple for us to keep us from getting our wires miscrossed.
Makes sense.
You bet. Now I'm going to fold this down, turn it over, take our wires off, and go wire for wire. And our two clock motor wires. Make sure they're all nice and snug and on with a good connection. We'll move these aside, place that in there, take our screws, set it right in there. And there we go. Okay, now I feel rest assured that that's going to take care of our problem and everything's going to be just fine. Again, we'll have another happy customer.
All right. Remember, Spa Parts Plus carries all the products that you've seen in this video. So call Spa Parts Plus at 1-800-521-7587 for a free catalog or to get more information.